Hi, my name's Kenneth Chaney, and I am going to be showing some work. My paper is Learning Event-Based Height from Plane and Parallax. This was done in conjunction with Alex Zhu and my advisor, Daniilidis. We leverage the EV-FlowNet architecture with a novel loss based around the plane and parallax methods to predict the height and depth of the scene in a coupled manner. Essentially, the plane and parallax setup relates the height and depth of an object in the scene with the ground plane information and the odometry of the camera motion. Okay. In simulation, sorry, I apologize. What the slide would have showed was the on top the projection of the events over time with just standard projective geometry, and then at the bottom warping, where you would see a parallax effect as you go up in the scene due to the change in the height, because the ground plane homography can only correct for points exactly on the ground plane. This is an example in the MVSEC dataset. You can see very clearly the points on the ground itself is fully corrected, whereas the points going up above the ground need more correction yet. This is where the residual flow comes in, which is fully parameterized by the height and the depth. During training, we need the odometry and the ground plane calibration. During inference, we only need the camera to ground calibration in order to pull out the separate height and depth. And then this would be results. So we evaluate on the MVSEC data set itself, and we show results on all of the outdoor night scenes. In addition to the motorcycle scenes where we don't actually have any of the ground truth information, and we simply just estimate the homography in order to provide some qualitative results. And quick plug for the MVSEC dataset, which our group has released open source.